Hello everyone. Welcome to the video lectures. I am Professor Mayur Gohil. In this video lecture, I shall be taking up the above question to solve for the consistency of the system or examine the consistency of the system, and we have to solve if found consistent. Now let us see how to handle this. So the answer, always write the system carefully, and we will directly now write the system in the matrix notation. So in the matrix notation, the above system is ax equal to b, that is, so this is how it is written. Now we write the augmented matrix, and so we go for consistency checking basically directly. So we write down this heading here. So to check for consistency, we say here, consider the augmented matrix AB 214 minus 1 2 minus 7 minus 1 1 minus 5 and 2 2 2. This is the matrix we consider. Now we will see how to get the rank of it. So the first thing what we do, we perform the row operations here and we find the rank. Okay, so using row transformations only. So let us perform here. So perform R1 interchange with R2, because we want to make it row echelon form. So let us see how to do that. So R1 interchange with R2. So here I have this. So here we will have 2 minus 1, and then there is 2, and here there is 4 minus 7 and minus 5, and here there is 2. Okay, now we perform the following row transformation. So perform R2 changing to R2 minus 2 R1, and R3 changing to R3 minus 4 R1. So we get here 1 2 1 2, and here this is going to become 0 0. Okay, these elements will become 0, but now we have to do the calculation for the remaining one. So let us see what will happen, because the intention is to bring the matrix into row echelon form as much as possible. So let us see how we can reduce it. So here this minus 1 we will be getting here, instead of minus 1 we will have minus 1 minus 2 times 2. So that is going to be minus 1 minus 4, which is minus of 5. So here we will have minus 5. So here it is minus of 5. Here again there is minus 1 minus 2 into 1, so that is minus of 3. So this is minus 3. Here it is going to be 2 minus 2 times 2, so that is 2 minus 4, that is minus of 2. Here it is minus 2. The next one we have 4 here, and that is gone 0, and but here we need is, what is there is 7, and then there is minus 4 times 2, so that is going to be minus 7 minus 8, so that is minus of 15. So this is minus 15. Then there is minus of 5, then there is 4, and then there is 1, so that is minus of 9. So here it is minus 9, and here it is 2, 4 and 2, so that is 2 minus 8, that is going to be minus of 6. So we have minus 6 here. Now we perform R3 changing to R3 minus, or it's triple of the that row, right? second R3 changing to R3 minus 3R2. So 1 2 1 2 0 minus 5 minus 3 minus 2, and here what we will get is 0 0 0 and here 0. So that's there. So this is what we have got, and this is the ultimate. After this there is no point in solving further for row echelon form, because this is what is the row echelon form right now. So now we go for the analysis portion and solve if found consistent and etc etc stuff. So let us see what is the understanding from what we have done this calculation, and let us understand if there is anything more to be done. So the matrix over here is this. Okay, so this is the row echelon form, and rank of A over here is 2. Okay, the rank of A, because as I said that we are working for row echelon form, so row echelon form definition is like, because number of non-zero rows, right? Non-zero rows in A. Same is the definition for rank of AB, the number of non-zero rows in AB. You can see, you just delete this line, the dividing line here, so you can see that it is going to be again 2. So I directly write here that rank of AB is 2. Now what did we see from consistency? We get therefore system is consistent. What does this mean? It means that there there exists a solution to the system. Now what kind of solution, that is what we have to see. So that is what they have written: solve if found consistent. So it is found to be consistent, so we have to solve it. So what and how we solve it, let us see. So the matrix that we have obtained finally after reducing it to the row echelon form, we will use that matrix here. So we see here there are two equations, and the unknowns are how many? We can see the unknowns are 3, right? So we also write down that information here, so that here we see that num number of unknowns is n, which is equal to 3. Also we see that now we write down from this uh, row echelon form of this matrix, the augmented matrix, we can write that x plus 2y plus z is equals to 2, and minus of 5y minus 3z is equals to minus of 2. This is what we have got. Now for solving purpose of the solution of this, we will use the information that since rank of A is equals to 2 and n is equals to 3, therefore we can call this rank, we'll call this R, and so n minus R is 3 minus 2, which is 1. This is number of free variables. Okay, free variable. So we are allowed to choose one variable free of our choice. That can be any one which we want. So the thing is going to be like this here. So from these two, from these two, I'll call this as a star, and we will use it further. So from star, we have minus of 5y minus of 3z is equals to minus of 2, which is same as 5y plus 3z is equals to 2. Now we can write here, I'll set up one variable free, it is independent. So what I will do is y is equals to 2 minus of 3z divided by 5. This is what can be written from the given equation set. Now we put this value, we put y equal to 2 minus 3z over 5, okay, in the other equation which was there in star, that is in x plus 2y plus z is equals to 2. So we get here, therefore x plus 2 times 2 minus 3z over 5 plus z is equals to 2. Therefore x plus 4 minus 6z over 5 plus z is equals to 2. So therefore x plus 4 minus 6z plus 5z over 5 is equals to 2. Therefore x plus 4 minus of z over 5 is 2, which means x is equals to 2 minus 4 minus z over 5, which is 10 minus 4 plus z over 5, which is 6 plus z over 5. We get that. So the vector which we want to form, so see x, y, z, right? This is the vector for which we are solving. Now for x we have got an expression in terms of z, that is 6 plus z over 5. For y we have got 2 minus 3z over 5, and for z it is all z again, right? So where, and here we write where z is arbitrary. Okay, so this is the solution for the given question. So this is the 8-mark question in your examination, and that's how you solve it. Now in some of the books they free the variable and use here n equals to 3, and they write this information. Some of them don't even write this information, but it's, I think it's much detail, and so if you write this detail you would fetch some marks. But here at this stage what do they do is when they shift the variable, they choose one variable, then they put z equal to t. I feel, I don't think there is any need to introduce a new variable. You can just work down the entire solution with one same variable and just change the role of the variable. Okay, so that's what it is. This is how mathematics works. Rather than inserting more variables, you can get a much simpler solution within the variables itself. So this is the answer for the question which was asked in one of the examinations. I hope you like the solution. Please hit like button. Please share it with your friends, those who find this topic useful. Please subscribe to my channel. I'll see you in the next video lecture with a new question. Thank you.